How is it possible to extract oil from a grain that feels completely dry to the touch? What looks like a simple golden oil on a supermarket shelf is actually born from one of the most extreme and precise processes in modern industry. Imagine millions of corn kernels, hard and dry, being transformed into pure liquid by machines working so fast they seem to defy human vision. Every second, tons of grain pour into metal hoppers that swallow everything as if they were hungry. And this is just the gateway to one of the most impressive industrial chains in the world. The production of corn oil involves intense temperatures, grinding as fine as dust, and a sequence of steps so delicate that a single mistake can turn entire batches into waste. If you're new here, welcome to Factories and Facts, the place where we open doors almost no one ever sees. Now, before moving on to the next stages, and they are jaw-dropping, take a moment to subscribe here on the Factories and Facts channel. Already subscribed? Then tell me, what other everyday food do you think goes through the most brutal process before reaching your table? Let me know down in the comments. Right after this first brutal selection of the grains comes a curious detail. If you watched our last episode about olive oil, you'll notice that corn oil follows a completely opposite path, where delicacy gives way to raw force and heavy engineering. It's almost like comparing a handcrafted surgery to a colossal industrial operation. And this is exactly where the story begins. Sensors analyzing each kernel in fractions of a second, machines separating impurities with clinical precision, and metal giants moving tons as if they were feathers. All of this to ensure that only perfect corn enters this mechanical ritual that turns the impossible into oil. The first shock when entering a corn oil factory is realizing the absurd scale of everything. Trucks dump mountains of corn into gigantic silos, capable of feeding an entire city. Each kernel passes through optical sensors that analyze color, brightness, and micro defects in fractions of a second. It's an unforgiving screening. Only corn with ideal moisture and starch moves forward. After selection comes washing and precise drying. Here, every detail matters. Just 1% extra moisture can compromise extraction yield, affecting temperature, pressure, and press efficiency. It's like training an athlete. Nothing can be off. The next step is milling, where the corn is crushed into a dense meal. Roller mills separate the husk, germ, and starch. And it's in the germ, the smallest part of the kernel, that the real treasure lies. A surprising fact for many people, out of 100 kilograms of corn, less than 5 kilograms actually have real potential to produce oil. The rest becomes flour, animal feed, and industrial byproducts. Nothing goes to waste. With the germ isolated, mechanical pressing begins. Imagine a steel screw compressing the material with such force that the temperature rises instantly. Crude oil flows through narrow gaps, while the dry residue, the cake, moves on to another treatment. Even so, this powerful press extracts only about 60% of the total oil. A lot is still hidden in the meal, and that's where the most sensitive stage comes in. Solvent extraction. Hexane, the most common solvent, passes through the meal like a fine rain, dissolving the remaining oil. The result is the micella, a mixture of oil and solvent. In evaporators, the hexane is removed and recovered with impressive efficiency. Over 99% returns to the system. The crude oil moves on to heated tanks, dark and strong smelling, waiting for purification. The solid residue goes through a dissolventizing process, becoming protein-rich animal feed. The chain is so efficient that some factories reuse excess heat to generate steam, making the process almost self-sustaining. But before we move on, let me ask you something. Are you enjoying this deep dive into the engineering behind corn oil? Then leave a like here on Factories and Facts. It really helps bring more industrial, behind-the-scenes stories to the channel. And you know what's incredible? Despite all this massive structure, the oil represents less than 5% of the grain's total value. The process only exists because everything around it, meal, starch, feed, keeps the operation profitable. And now that you've seen how oil is born from raw force combined with chemical precision, we're about to enter the phase that will transform this dark, impure liquid into a clear, smooth, edible product. And it's exactly in this next stage that true industrial alchemy begins. The crude oil that comes out of extraction is still very far from the golden liquid you see on store shelves. It reaches the tanks with a dark color, an intense smell, and filled with microscopic particles that must be removed with absolute precision. This is where the most delicate and at the same time most elegant phase of the process begins: purification. Each stage works like a filter, gradually refining the oil until it becomes clear, light, and completely safe for consumption. The first major step is degumming. The oil is heated and mixed with treated water. This water reacts with phospholipids, forming a thick, gum-like substance that naturally separates from the oil. Once this gum is removed, the liquid already begins to take on a more uniform appearance. What's interesting is that this gum, which many people assume is discarded, is reused by the pharmaceutical and animal feed industries. Nothing goes to waste. And that's exactly what makes this process so fascinating. Every byproduct finds a new purpose. After degumming comes neutralization, responsible for removing free fatty acids. These acids would give the oil an unpleasant taste and reduce its shelf life. To eliminate them, the oil is mixed with a mild alkaline solution, usually sodium hydroxide. This solution reacts with the acids, turning them into soaps that settle at the bottom of the tanks. It's as if the oil goes through a chemical bath that restores its essential purity. Science acts on what's invisible to the eye, but clearly noticeable in the final aroma and flavor. The next stage is bleaching, a process that involves special clays capable of capturing even smaller impurities. These clays act like microscopic magnets for pigments, metals, and organic residues that survived earlier phases. When the oil passes through large filters filled with this material, it emerges visibly lighter. It's an almost hypnotic moment to watch. Dark oil transforms into a pale, translucent liquid right before your eyes. But even after all this progress, one essential step remains: deodorization. The name may sound simple, but the process is remarkable. The oil is heated to extremely high temperatures inside vacuum chambers, causing volatile compounds, responsible for strong odors and flavors, to evaporate completely. This combination of heat and lack of oxygen creates the perfect environment to eliminate anything that could compromise the smooth aroma of the final product. The result is a light, neutral oil, ready to be used in all kinds of cooking. At this point, it's worth pausing to reflect on the complexity of this transformation. We start with dry grains, with virtually no oily appearance, and end up with a delicate, crystal clear, stable liquid. It's a massive leap, and each stage depends on the previous one with almost surgical precision. Taking advantage of this moment, let me ask you, which stage of this purification impressed you the most so far? Leave a comment below and let us know where you're watching Factories and Facts from. Back to the process. The final part of this act is final filtration, where the oil passes through ultrafine membranes that remove any remaining traces of clay, soaps, particles, or unwanted compounds. It's no exaggeration to say that this filtration works almost like an invisible sieve, separating perfect oil from any microscopic imperfection. When this stage ends, the oil is officially ready for the next phase, final refining and bottling. From here on, ultra-fast machines take control, filling, sealing, and labeling thousands of bottles per minute. This is the stage you're about to see now, and you'll be amazed by the speed of these production lines. When the oil leaves purification, it's already clean and edible, but it still needs to go through the step that ensures stability, shine, and neutral flavor for months. Final refining. This phase combines thermal precision, advanced filtration, and strict quality controls. The oil is heated once again, this time in an extremely controlled way, to adjust its viscosity and remove any trace that could compromise shelf life. Sensors spread throughout the pipelines monitor temperature, pressure, and flow in real time, like invisible guardians ensuring everything is perfect before moving forward. Next, the oil reaches the polishing lines, where it passes through microfilters capable of retaining particles so small that conventional equipment wouldn't even detect them. It's impressive to see massive machines dedicated to refining such a light liquid. With each new filtration, the oil gains more transparency, until it reaches that characteristic shine consumers recognize on store shelves. It's one of the most elegant moments in the entire factory. With the oil fully ready, we arrive at the most impressive point of this act, the bottling line, a true mechanical ballet. Imagine dozens of empty bottles being aligned with millimeter precision, while robotic arms position them on the conveyor belt. Next, filling nozzles descend in perfect synchronization, releasing the exact amount of oil into each bottle. There's no waste, no error. It's like watching a perfectly rehearsed industrial choreography. And here's a number that always surprises visitors. Some production lines can fill more than 600 bottles per minute, an astonishing figure. That means that in less than 10 seconds, a single machine produces enough bottles to supply a small local market. The combination of speed and precision is so extreme that if a sensor detects any flaw, a crooked label, incorrect volume, or poorly fitted cap, the bottle is instantly removed from the line by a robotic arm. Nothing goes unnoticed. After filling, the bottles move to the sealing stations, where caps are applied with calibrated torque. The force must be exact, strong enough to prevent leaks, but never excessive, so the consumer can open it easily. Then the bottles pass through labeling machines that use air jets to fix each label without bubbles or wrinkles. The result is an aesthetically perfect bottle, ready for display. But the process doesn't stop there. Before packaging, all bottles go through an optical inspection stage where high-resolution cameras analyze color, transparency, and fill level. If the oil is even slightly outside the color standard, even if it's imperceptible to the human eye, the system automatically identifies and rejects it. It's a final barrier that ensures only the very best is distributed. After inspection, we reach packaging, where machines assemble cardboard boxes in seconds and arrange bottles in perfect rows. Automatic palletizers stack these boxes into massive blocks, ready for transport. Each pallet can carry hundreds of bottles, and in large factories, dozens of these pallets leave every hour toward distribution centers around the world. It's at this moment that the scale of the process becomes undeniable. From dry, hard grains to perfectly sealed bottles, corn oil goes through a journey of raw force, chemical delicacy, robotic precision, and almost obsessive quality control. All of this to ensure the final product reaches consumers pure, safe, and stable. Next, we're going to explore the global impact of this oil, its logistical journey, and reveal a surprising fact about uses that go far beyond the kitchen. When the bottles leave the factory, a stage as complex as the entire production process begins: distribution. Giant pallets move toward logistics centers that operate like automated cities. There, intelligent systems organize everything by region, demand, and production date. Each batch has a specific destination, and nothing can fall outside the plan. The entire chain depends on this precision to ensure the oil always reaches store shelves fresh. It's curious to think that such a common product has such a massive global impact. Corn oil is used in restaurants, bakeries, fast food chains, and food industries. Its stability and neutral flavor make it one of the top choices for professional frying. In some countries, it's so popular that it even surpasses soybean oil in total sales. That preference only exists because all the engineering you've seen so far guarantees an extremely high-quality standard. But the lesser-known side of this story is even more impressive. Corn oil also has non-food uses. It's involved in the production of paints, lubricants, cosmetic products, and even bioplastics. Its composition allows chemical modifications that make it versatile and valuable across multiple industries. It's as if the oil has a dual identity: food in the kitchen and an essential tool in complex sectors of the economy. A curiosity even many professionals don't know is that part of corn oil is used in the production of medicines, especially coated tablets. The oil acts as a lubricant in tablet presses, ensuring pills don't stick and that the coating remains uniform. Yet another example of how a simple grain can influence completely different areas of human life. When it reaches the supermarket, a journey of hundreds of kilometers finally comes to an end. Each bottle, aligned and shining on the shelf, carries within it a story of immense forces, precision sensors, extreme heat, and sophisticated engineering. It's impressive to imagine the path taken from an almost dry grain to the clear liquid inside the bottle, a process most people have never stopped to consider. Corn oil's impact is also felt in international trade. Countries that produce corn on a large scale use the oil as a strategic export product. It's stable, easy to transport, and highly valued. In some ports, it's loaded into massive tanks, similar to those used for fuels, and crosses oceans to supply markets and industries on the other side of the world. At the end of this journey, it becomes clear that corn oil is not just an ingredient. It's the result of raw force, precise chemistry, high-speed robotics, and monumental logistics. An entire chain of people and machines works in perfect synchronization to deliver a product that seems simple but carries enormous science, technology, and economic impact. And now I ask you, after following this entire journey, which part of this chain did you never imagine was so complex? Leave a comment below. And of course, if you're not subscribed yet to the Factories and Facts channel, now's the time to subscribe because there are still many industrial behind-the-scenes stories to reveal. And if you think you've already seen everything, then you can't imagine the factory we showed in our last video. It's already appearing on your screen. Click and come with me to discover another hidden secret here on Factories and Facts. A big hug. I'll see you there.